Okay, hi, and welcome to our virtual Chicago meetup. Today we are joined by Praveen and Vatsal from Egen Solutions. They will be giving a presentation here shortly, but if you have any questions throughout the session today, please feel free to post those in the chat window and we'll have time for Q&A at the end. So with that, Praveen and Vatsal, I'll turn it over to you.
Hey everyone. I'm Praveen. I'm one of the data engineers at Egen. Just give me a second. Let me share the screen. Yeah. Yep. Can you guys see the screen?
Yeah, it's visible.
Yeah. So today we're gonna have a discussion about how to implement the document search feature using Elasticsearch. What this basically means is like how to open the contents of the document and then like search inside the document and retrieve it. So this is basically the overview of the session here. And before we start, I'll have a few words about Egen. And so at Egen, we are like mostly with cloud and data engineering experts, and we do a lot of modernization stuff and also build ETL pipelines for our clients. And we work with like most of the unicorns and enterprises across Chicagoland and also across US as well. We are partnered with the most leading cloud providers like AWS, Azure, and GCP. Also, we have partnerships with Elasticsearch and Confluent as well. Yeah, for the past 6 years, like we've been in industrial IoT, domain, retail, healthcare, and fintech, and recently we started working with HR, payroll domain as well. Yeah, so this is about Agent and what we do here. And now for the agenda of the session. So first we'll see how a basic document search flow would be, the architecture of it, and then like we'll see the features that are provided by Elasticsearch for document cracking and searching. Then we'll like discuss in detail about the ingest nodes and the pipelines which Elasticsearch provide, and the ingest attachment processor for that, and also like the text analysis for the pre-processing of this text. And we'll have a hands-on demo session as well after those. And then we'll see how to securely uh, s- store the information in the Elastic. Say if your organization has some kind of complaints issues, say like they have HIPAA complaints, or cannot store openly the contents of the file in that. So what can we do in those scenarios? And yeah, so here's the document search flow. So initially, like we have our documents and images here, which are needs to be like extracted, the contents of this to be extracted. So for this, like initially we need a document uploader. So this document uploader needs to do two things. So one, it should have it uploaded to a blob storage, so that like when we store the files and like when we need them we to retrieve later for the search, like we'll like retrieve them from blob storage. And also it needs to do is to upload, like send it to the document cracker. So once we store it, like we also need to crack open these documents, right? So we need to extract these documents and like have the search on top of it, correct? So we need this document uploader to do both these things. Yeah. And basically like we can have a Kafka or like PubSub structure for this document uploader to get started with. And for the document tracker, it first needs to extract the information from the document and like convert it to a text. And then like there will be a lot of junk with this text, right? So which are extracted from the document, PPT, Excel, and PDF stuff. So we'll need to clean up these texts as well in the document tracker. So that's an important step. And if we are looking at images, we'll need to have an additional step of OCR for this as well. So these are all need to be taken care by the document cracker. Now once the document is cracked and the text is extracted and cleaned up, we'll need to store them in a data store, correct? So that's the next step in the flow. So once we store and index and store these files there, and now comes the search part. So we have our data sitting in the data store, and we need the user to have like search string, and then like we need to extract the particular file for those search string, right? So we give us like we extract the text, the search string from the user. We build a search query on top of it, and then like we need to we did a processing, kind of pre-processing in the contents of that document, right? So we also need to do the same with the search query as well, so that we match the exact contents. So we'll like look into that step like later in the presentation. Once that cleanup is done, we'll like hit the query into the data store and like retrieve the details of those documents. And then once we have these details, like we extract the original file from the blob store, and then like send it back to the front end or the user. Yeah. So this is the typical flow of the data search, like document search. Now we'll like look in detail about the document cracker, data store, and the document search API piece. Mm. So for document cracker, first we need like the first step is like we need to like extract this document to a plain text, like all the formats. Like we need to handle all the formats as well: PDF, PNG, document, Excel, PPT, and everything. So that is one main important requirement for the document cracker. And also, once these plain texts are extracted, we need to clean these up. So there will be a lot of extra punctuation marks, and there will be like a lot of junk and like say characters which are not part of the alphabets as well, like punctuations and stuff. So we need to clean those up. So some of the cleaning techniques that we have for like we recommend, or like that is like most common like pre-processing techniques, like which we have given here, like tokenizing. Tokenizing is like splits these words by in a sentence. Like it just say if we have clean up the raw text, like it just by the condition or the white space, it just like extracts these like words, like clean up in like. So that's how tokenization works. Like it just picks up the individual words from these sentences using white spaces or punctuation depending on the setting which we have. And also like we need to like lowercase letters so that we maintain a common pattern across all these documents. And like most of our like text documents are filled with a lot of stop words, like the and so we don't need these stop words to be stored in our data store. And like it saves a huge lot of space, and also like it like screws up the search if we have these stop words, right? So we need to remove those as well. And stemming is a technique where each word is like converted into its root word. So we have an example here, say like whatever we have here, like the consultant and consulting. So everything is like ripped off and like it's stored as its root word consult. So whatever the user has in this document, like has, like it is like converted into its root word and stored in the data store. This is also handled, should be handled, yeah. And so once these data is cleaned up, we need the document character to store it in the data store. So now we'll go to into data store, then like what is expected of a data store. And say we upload a lot of documents, right? So we need to handle a big amount of data there in a very efficient way. So that is the main initial requirement for the data store. And also we need to have these text analysis which we are speaking in the document cracker as also part of the data store. It should understand these stuff. So and then uh, have these search queries with like when we hit a search keyword in the front end, like it should like run the query in milliseconds and then like give the document back to the user, right? That is also one recommended. And also we need the data store to have the path and reference for the metadata for the original file text, which is stored in the blob storage as well. So that is there. Now for the document search API, so we need to do the reverse thing for the search key. So the document search API should handle these tokenizing lowercase, remove stop words, and stemming for the for the search keyword as well. So we need to do that in this document search API. And also we like we build up, of course we build up the queries and hit the data store with that. Now once the document information is retrieved, like we go back to the blob store and then we extract these raw files from the blob store and send it back to the user. So that's the main part of the document search API. Now let's see. Let's come to the data store. Now the best obvious solution for the data store here is Elasticsearch. Like it's the lead in the market, and like we have no other doubts here. So we'll use Elasticsearch. Now what about document cracker? So do we code the document cracker separately in some language, Python, C sharp or something, and like handle a lot of stuff here, or like what else we have in the option here? So that's where Elasticsearch comes with its ingest pipeline and ingest attachment plugin features. So it takes care of these stuff for you, and like with less effort. So like it just handles the document cracking piece, the pre-processing stuff, everything on its own. The Elasticsearch has the features, and you just have to replace them. And like it just like you can index crack the document, index it, and then like directly hit with the search query to retrieve those documents. So that's how that is an feature which is provided by Elasticsearch, and like we'll discuss that in detail in the next slide. And now we'll speak about the ingest node. So ingest node is a special type of node. So like Elasticsearch basically has a list of node types for specifically for purposes. Say it has master nodes to handle the processing and data nodes to store the data, and we have ingest node, machine learning nodes. Ingest node is basically to handle all the ingestion into the Elasticsearch. Say we have a lot of data coming in into Elasticsearch, and we cannot have the master node handle everything, right? So we need to separate these load and have a separate node to like handle these ingestion stuff. So we Elasticsearch provides a separate node type for this, and it's called the ingest node. Just like we have to just have the ingest role in node dot role as ingest in the setup, and like we have this node spinning up there. This ingest node like executes pre-processing pipelines which we were speaking earlier, like say lowercase, remove the fields, and like transforms the data in like whatever format we need based on use cases. We can handle that in the processor. And yeah, that's what we're talking about, the transforms the inbound data. Now for this text processing and like ingest data, like document cracking piece, we'll need to have in dedicated ingest nodes, because like it is ingest heavy, and also we need to have the pipeline set up there. So without the ingest nodes, like we cannot have this document search feature set up in the Elasticsearch cluster. So we need to have this ingest node there. And ingest pipeline is basically like we handle uh, it in like step by step process. So first crack the document and remove these unnecessary fields, and extract these values from there, and like do the pre-processing there, enrich your data. Like say I don't want the stop words, I don't want the punctuations, do those. So yeah, so these stuff are like can be handled by process, like individual process in the pipeline. So pipeline can be built with individual process. So first we'll have say a lowercase processor, and then once the text is converted to lowercase, we'll then have them remove the stopwatch kind of stuff. Yeah, that's how process work. Elasticsearch provides a list of process, like you can see the process here, right? Append bytes. So these are the type of process which you have, and also we can create our own customized processor, and in the backend, and like we just have to rebuild the Elasticsearch package and then again deploy it. So there are a lot of stuff we can do with the processes and do the pre-processing based on our use cases. Now I'll just share like hand over to Vatsal to handle the remaining of the sessions and stop the screen share. Yeah.
Yeah, thank you. I'll just go ahead and share my screen. Yeah. So yeah, we get started. Yeah. So just to give you like an example of the ingest processor, I have there are like inbuilt processor ingest processor that are provided by Elasticsearch, uh, like GeoIP and trim. Trim like clears the white space, like the uh, trailing white space, and GeoIP. If you provide like a field with a IP address like IPv4, IPv6, it will provide the geolocation IP information using that. Uh, yeah. So what I have in Kibana, I had created like a sample pipeline GeoIP example, uh, and in that I used these two processors, trim and GeoIP. Uh, the field on which the trim will work on is like a field called IP, which will be part of our Elasticsearch document. So that what trim will do is like clear everything and like the trailing white spaces, and then another processor will work on the same IP field, and enrich the document, the Elasticsearch document with the location information about that IP. So I already had done it, this example previously run on like a Kibana Elasticsearch instance. Um, I create like a document with the IP. Yes, you can see there is like lots of like white space trailing and like in the start. Um, if we give this document to the ingest processor GeoIP, it will give an error because it's expressed just like the IP string and nothing like the white space. So yeah, after this gets indexed, you can see there is like lots of information. We can go to the next slide. Yeah, as you can see, like the IP field, it changed it in place. The trim processor changed, removed all the white spaces forward and the trailing ones, and did the in place conversion to the same field. And then we can see like the GeoIP processor added like a like another field, object field, called GeoIP, with lots of information, location about that IP address. So like for this IP, the latest information available was like it was in Portland City in Oregon State, and it has provided like all the other information also, like the longitude and latitude. Um, yeah, moving on to the next slide. Yeah, ingest attachment plugin. So this attachment plugin lets the like the Elasticsearch extract file attachment in common format. So what it does is uses a Java library called like Apache Tika, which provides like text extraction facilities. So it handles like lots of formats, example PDF, XLS, for PPT, and lots of like there are like a huge number of formats it can handle and pass and give text extraction for. So this does not come with the default Elastic Cluster setup with the ingest node, so it should be installed separately on each node. This is just like the sample, like the command that could be used like Elasticsearch using the Elasticsearch plugin binary. You can install it to like all the nodes. Um, Moving on to the next slide, like the text analyzer, which will be required for like document, which could be useful in document like searching. Um, just to a little bit information about the analyzer. Analyzer, like whether built-in or like the custom one, which is the package which contains like three building blocks, basic building block: character filter. You can go like each one by one character. It goes through the stream of characters and filter, and it does the filter on those. Tokenizer, like tokenize like each word and like using the conditions it has been provided. Token filters, like same filter on the tokens, like maybe we don't want certain tokens like punctuations and stuff we don't require. Uh, Analyzer can be customized based on use cases. If you have different use cases, you can customize for like simple, like a small amount of text you want like a different analyzer for document. You would require like something like stemming and something lemmatizing. So yeah, you can create like analyzer based on your use cases. Like you have like sample like for the most used one for documents, maybe like the tokenizer would be like standard. It and white space standard would remove all the punctuation from the text. Token filters like ASCII folding would like to change the Latin accented Latin character to the normal ASCII. Stemmer, Praveen had already showed like an example of stemmer synonym, like you are like synonymous word. So you want to match on both of them when you search. Lowercase is like straightforward, like lowercase everything. Yeah. So we had already created like a index for this demo, like and analyzer we use was like a custom kind, like with a tokenizer like standard and a char filter, character filter that was used was HTML strip. HTML strip would like remove every like say like text has like certain HTML code like for like in the example you can see there is a like a B tag, so it would remove that B tag. We have filters. Stop is for like removing the stop word uh, that you don't want to search again. Like that makes sense. Like it will remove that, off that, not, uh, and like sky folding would remove the accidental word, and stemmer would stem the word like based on we using the analyzer you can see like the text that has like lots of characters that we wouldn't want to search on, lots of stuff or like off that, and like hyphens and stuff. Also like there is like HTML tag v there, that we won't want conservative. Yeah, so yeah. So after that, you can see that after using analyze feature by Elasticsearch, you can see like the token available. Like from that text, the only token that are left after all the processing is done by the analyzer is like extreme. The stem word for extremely is extreme in this case. For conservative, it is like conserve. For help, it is helping. It is help, and for hand, it is hand. It would remove like not and the tag and off and everything else. Yeah, so I'll go ahead with like my demo after this for like ingest attachment processor and ingest pipeline. Yeah, so that's like a this is the cluster setup that we have, like three master nodes, three data node, two in dedicated ingest node, using Elastic Cloud Operator on Kubernetes. We have deployed. Going back to now, I'll show like I'll show like the Kibana for now. So yeah, let me get started. Yeah, so I have already created like a pipeline which is used in the document index. This is like a default pipeline. Uh, so here we have like attachment. Attachment is the one where attachment is the plugin in this attachment plugin which will actually parse the data files for us. It requires like a base 64 encoded string. So right now we have said like the our document which will go through which you want to put it in like Elasticsearch. It will have a field called data, and this is where uh, like the base encoded string is, base 64 encoded string is. Then we are uh, having like a lowercase pipelines preprocessors uh, processing on like so what attachment will do is like create like a one more field called attachment, which will have like metadata of the files and fields like content and title. Content will have the document content, and the title will be extracted like from the file and put in like a title field. So we just want to like lowercase pre-process uh, the content and the title and lowercase it. So I have another condition called ignore missing. So there may be a case like the attachment plugin was not able to parse the title, or there wasn't any title in there. So we don't want to error out. We can just ignore that in that case. And then another processor called remove is used. What remove does is like it removes the field that are not required. So in this case, we can remove the data field because it's not required anymore, and we don't want to take up the any space. Yeah. Uh, yeah, I will show. I have created like a small demo in using like fast API. This is like this Swagger endpoint. What this will do is like take a file, multi-part form data, and then it will like just upload it to the RESTful API and post it there. And let me show. Yeah, I have some example documents. Let me go like few. Yes, so this is the document I want to upload, the sample document that I have. I will upload this first. Yeah, so the response was true, which means like it's indexed in the collected index. Let me show you complete index. So collected info is the one where we have the document index. I'm just searching everything. So as you can see, yeah, so you can see like parsed out from the document and stored it as a plain text, and also has like a metadata date when it was created, like some keywords of it extracted, content type, the MIME type is like PDF because this is a PDF file, language it so that it's like English, title like PDF, PDF, and you can see like the content is there. Yeah. So this was one of the thing. Like we upload like another document with a different file format. Yeah, I have Word file also. Upload that. Yeah, it also got successfully uh, indexed. Yeah, the second document, you can see like it has like the mine time is different. What found, what Apache Tika found for the Word document. It has like author, language, and the content. It have like a title, so it couldn't extract any title from the document file format. So it has all everything in plain text from the document. Yeah, I can like provide. So I can say I will upload just like one more document. So this one is the document. I will do the same thing again. Search it up. Yeah, you can see like it got the mine tab correct, and it has like the content also. It also found like a typing in the document. The content is it's the same in just like in text format, unified file format. It matches there what we had in the document. Yeah. Also, like I can show like a search on that using Kibana. Yeah, and search again like this like spelling word, and it matches like Google documents. So uh, so you can see like it in the search also works. It also will go through the same analyzer as in uh, 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 having the view the index used for the document. And I can show like a one more example of the search. Uh, Here I have used like a wildcard with a bool should. So this way we can search against the title and the document content. So we boosted like in the example, we give a, like a boost to the title because if like the title matches like it can we can give like higher preference to that, and we did a wildcard on that. So yeah, we can see this should have something uh, related to with that. So there is a word called word regardless in this document in this PDF. So these are matching. So this could also be used for like autocomplete in this case. And yeah, going back to the slides. Yeah, now those are like the what we can do for like if you like sensitive file content. So say like a certain organization has sensitive files and they are in a highly regulated environment and they are like they cannot store it in like plain check in US. What can we do in this case? Some use cases where like, sensitive file content is unnecessary. Uh, what if like we want like multi-tenant tenancy? The option is like in this case we can have like a separate cluster. If that is feasible and economical, we can use it if money is not an issue. Or like a better solution could be like having like an index per tenant in a shared ES cluster and use like some sort of index level access control per tenant. And another option is we can hash like each the whole content of the plain text word by word before ingesting in the ES cluster and apply all the text pre-processing because like that won't be possible after. So we can like have lowercase everything before remove the stop word, stem it or limitize it, and then hash it. Um, and then store the hash content in the ES cluster. And we can use the same apply the same logic for during the search query. So like lowercase it, clean everything like remove punctuation, white space, unnecessary characters, and all the same things. Disadvantage like you use like the text channel because it's just like hashed content now in the and for the search feature. Yes, like an example of this, uh, some example code like written in Python. So it show like the same things like file, get the file and then pass token. Yeah, just some example there. Any questions?
I added a question to the screen. I'm not sure if this is one we can answer on the meetup right now.
Yeah.
I'm looking at it. Yes.
Yeah. Sure. Yeah, I think answer this one. If there are any other questions.
I think that's all. We can follow up with the question on the screen and put some resources in the chat. But other than that, that's all. Praveen, do you have anything else you want to cover today?
No, that should be our plan for today. Just a document cracking piece.
Perfect. Well, thank you both for presenting today. And we'll be back next Wednesday with another meetup from our Egen friends. Shri will be giving a presentation. But if you have any questions, feel free to post them in the chat. If you're ever interested in presenting or hosting at a meetup, feel free to reach out to meetups@elastic.co. But thank you both and have a great rest of your day, everyone.
Thank you. Thank you for having us.
Bye.